Hello.
Hello, good morning.
Good morning.
Yeah, good morning, everybody.
Morning. Welcome, everybody.
Good morning.
Thank you.
We are waiting for Nikos, that is our moderator today. And I myself will be helping him with the parallel section. So I don't see Nikos, but I guess we can wait some minutes. In any case, I see that Gustavo and Claire are already in this session. That it's good because they will be sharing the slides. Am I right?
That's it. Yes. Hi. Okay. Hi, everyone. Yes. Can you all see the presentation already? I hope. Yeah, it's on screen. Great.
Perfectly.
And then yeah, just tell me next slide and yeah.
Excellent.
Yeah.
So the thing is that we are waiting for the
Nikos,
the principal moderator, Nikos, but I'm not sure if he's joining us today. Well, of course he is joining us today, but in this he has come to this parallel session. I saw him waiting at the lobby room, but I don't see here. Keep on accepting people to this meeting.
Maybe we can see if we can try writing to him.
Yes, if not, I can start, and then if he finally joins us, he can just step in and continue with the moderation. But just a brief presentation from me. My name is Santiago Gallego. And thank you very much. And as you see here, we have two moderators today, Nikos Haslargirlu and myself, Santiago Gallego. And I work for Iberdrola, that is a company very well known for being a worldwide energy company with a high commitment with renewable energies. That is specifically the question or the issue of today's panel. And I specifically hold the position of Regulation Manager for Europe and within our DSO branch, the distribution system operator. My presence here is also related to the fact that I am co-chair of working group 1 of ETIP SNET. I am a part of the ETIP SNET family then. So we have today with us 5 excellent panelists, and 4 of them are ready to provide us with excellent presentations with during 99-second pitch, and I'm going to present to introduce them just in a second. But first, I would like to make some general remarks about the rules of these meetings. And yes, the first one is that you have to switch off your microphone and camera, and because only panelists and moderators will have the camera and Microsoft on. You can use the chat on Teams, not on Slido, to write your questions. there will be a dedicated time to do it, but you can do it whenever you prefer, and then I will take note and I will check when it's time to address the question to our panelists, our participants. And also we have an Slido poll that you know, because we were using it at the general session. But in this parallel session, we are also asking some questions that we will use for the for the panelists to provide some inputs on the results. So this is the general rules, and I would like to introduce our panelists today, starting with I think John Lowry is the first one who is going to speak, and John is a project director at AirGrid, that it's the TSO of Ireland. John is currently leading the implementation of the AirGrid Group Innovation Strategy and is coordinator of the EU System Flex project. In previous roles, John has played a critical role in the establishment of the system services market in Ireland, as well as leading a major transmission infrastructure development and renewable grid connection across Ireland. John, you have 99 seconds to present your project.
Good morning, everybody. Thank you very much for having me here. I don't see the slides yet, so I assume my 99 seconds hasn't commenced. It's a short enough pitch, but look, hopefully I can give you a bit of insight into EU SysFlex and the value of it to the European power system.
Yeah,
I see Nikos has joined us now.
Sorry, yes, I think we're...
Hello, everybody. I'm really sorry for this.
I think we're skipping some steps. Sorry.
I'll hold off. So,
thank you, Santiago. Thank you very much for starting with this. Let's
No,
continue.
not at all. I think that we start with John, but probably we have the because this is the list I had. But of course, we can come back to Alex later on, if you don't mind. But whatever you want, Nikos, as you are here, we can start with Alexander. I just introduced it. Jonas said because I had this in the list, but if you want to start with Alexander Widerman, it's up to you, whatever you want.
Well, yeah, it doesn't matter. Alex perhaps could start because he will provide a more general view about how
perfect.
Thermal.
Sorry for that, Alexander.
Can help renewables. So, thank you, Alexander.
Yes, thanks a lot for your kind attention to this topic here. I will also try to be short within 99 seconds. My name is Alexander Widerman, working with Marine Energy Solutions, and I'm actually now the chair of the Working Group 3 Flexible Generation. And just going into the details, the next slide, please. Oh, there are some animations. So please, could you so one more. Yeah, okay, that's all. So on the working group of flexible generation, we have a global view on just the role of conventional and also renewable energy sources in the new energy system. We need to identify research needs. We need to be sure whether technologies are available, whether they have to be upgraded to a larger scale. And from our point of view, we of course look at the flexible generation in terms of sector coupling. And we also have here some technologies, gas turbine based, which couple the electricity sector and the heat sector, and probably also the phase out of coal, which is planned in many countries by 2030 or so, means that we, in the intermediate phase, we could also save a lot of carbon dioxide and just switching from coal to gas. But of course, we are also looking at the future And we see that there are two very important facts here which have to be looked at. This is the fuel flexibility on one side. This means the capability of the conventional power generation techniques to switch on to green fuels. And of course, we have also load flexibility characteristics. We see that probably in the future, we will switch from the old central power generation to more decentralized issues, and this means that, of course, we need to check in how far so they, for instance, thermal plants or gas turbine-based plants could come in to stabilize the grid. In those terms, where the renewables, wind energy and solar photovoltaic are not available to this amount. Of course, in the future, we need a very powerful transmission system. We need also a very, very strong intervention between the user and the producers. But of course, if there's darkness in Finland or Norway, it doesn't help if sun shines in Greece and in Italy. Because the transmission systems probably also in the future will not be available to this amount. We also have to think a little bit decentralized. And the next slide shows, the 99 seconds are very short. Next slide, please. So the way we have to go in the future, and we see that in 2018, I think this is a snapshot. We see that some of the sectors, as industry, residential in particular, transportation is has on a very low electrification level. That means that renewables do not reach them in that amount which we need to really lower the carbon emissions. And this means we need in the future an extensive electrification. Of course, this will be partly compensated by techniques of smart grids and, of course, of the saving of in energy by the consumers. But of course, basically, it is we need to bring wind energy, solar energy also to the transportation sector and to the other sectors, of course. And in terms of storage, we will see that in the future, we in step by step with the renewables, we need also to extend the storage capacities by a huge amount. And here you see a figure which shows that in Germany we need to go from gigawatt hour storage capacity, which we have currently, up to terawatt storage capacities. It means this is a factor of about 1,000. And it is very well known that so the thermal and the heat storage system has to be extended in very great detail. But of course, that one of the keys for the sector coupling will also power to gas, in particular the production of green hydrogen. And our hope is that using current technologies, developing current technologies and scaling them up, we'll have a scaling factor and scaling effect, which also makes green hydrogen in the future affordable for us. Yeah, that's what I could say in the 99 seconds. And of course, I'm happy to reply to some of your concerns or some questions during the panel. Thanks a lot.
Thank you very much, Alex. I would say that let's take the questions at the end, and then let's move to the panelists. And please introduce yourselves for starting. And
Nico, sorry, just a brief reminder for all the audience, just to please remember that you have the Slido questions to be answered, because we have very poor participation till the moment. So please go to Slido and try to answer the questions. Thank you. Sorry for interruption.
Yes, there are, exactly. Thank you. Maybe we can bring these up just now, just so you can see. There are 3 questions. Maybe we can answer just quickly now. So it's which country you're from, and then 2 more. So we can see Greece, obviously. And then the next one is which sector? And the final one is, for now, is which RNI needed for the wide implementation of RSC, renewable energy? Sorry to intervene then. Okay, I think we have some data collected for the first bit. So sorry, we can proceed. I think with the pitches. Thank you.
Yeah, thank you very much. That's a very interesting result. It's interesting to see that really you see balanced needs for the technical and the market issues, and also pilots, and while nobody votes for no more R&I needed. The reason why this does not up to 100% because you are allowed multiple answers here. But it's really interesting that it's really important to see that you see the need for R&I in almost all aspects. Okay, so thank you very much. Let's move to the panelists of the projects, and please introduce yourselves and before starting, and I will pass now the word back to Santiago to lead this part of the discussion.
No, I think John was already introduced it. So John, you can take the floor if you want. Let's hope that it's the last attempt to do it properly. Thank you very much.
That's fine, absolutely. We might move on to my slides. Just to say thank you very much for having me here this morning. It's an honor and a pleasure. In 99 seconds, I'll try and give you a flavour of what the EU SysFlex project is about, which is a big challenge given that there's 34 partners involved in this project across 15 jurisdictions. So it's quite a complex project and a very broad project. So maybe we'll make a start and move on to the first slide. So what I would say about EU SysFlex, if we can move on to the first slide. That's possible. Back one slide. So at the heart of EU SysFlex project is the identification of system-wide challenges associated with the integration of 50% RESI across the European power system by 2030. And over the past 4 years, we're coming to the end of our project, and we've analysed the pan-European power system to identify what technical scarcities arise as we transition towards a power system dominated by non-synchronous variable renewables, namely wind and solar. And we've identified that existing energy market structures must evolve to incentivize the necessary investment in low carbon generation or the required volume of flexibility and system services to address the identified technical scarcities. All of this work is culminating in the development of a flexibility roadmap for Europe, which will be unveiled at the completion of our project next February. We can move on to the second slide. And looking a bit more deeply, we have identified that a significant set of scarcities arise as we move towards 2030 and as we move towards a system which is dominated by variable renewables. And in parallel, through development of 7 demonstration projects and technology trials across Germany, Portugal, Italy, Finland, France, Poland, Estonia, and Ireland, we've identified flexible capability of technology to provide services to grid, as well as exploring system operation tools, cross-border and cross-sectoral data management and exchange. And all of this is to support European power system integration and operation in a high-res environment. So that's my 99-second pitch. I hope I met the time criteria. Thank you.
Very good, John, and very accurate timing. Okay, next panelist is Katharina Valadkabi, sorry for the for the spelling, but Katharina holds a diploma in electrical and computer engineering from the National Technical University of Athens and PhD in electronics and nanotechnology from the University of Grenoble-Alpes. She is currently working as a project manager at Hypertech as a technical manager of the FlexScope project and project coordination of the Merlon and Cogito projects. She is mainly involved in research activities at the intersection of IoT and smart grids, and also in delivering cutting-edge demand-side management solutions appealing to various stakeholders involved in the electricity market. So, Katharina, the floor is yours. You have 99 seconds. Thank you very much.
Thank you very much, Santiago. Thank you also at ETIP SNET for this opportunity to discuss and exchange ideas in the energy transition. So let's start with the Merlon project. Merlon actually means Integrated Modular Energy Systems and Local Flexibility Trading for Neural Energy Islands. Our consortium is composed of 13 partners spanning around the EU. With Hypertech Energy Labs as a coordinator. This is a 3-year project. We are currently running the 3rd and final year, demonstrating our complete solution to 2 pilot sites. Merlon has established already synergies with Bridge Initiative, Clean Energy for EU Islands, and fosters EU-India collaboration. So if you go to the next slide, please. Let's check what is Merlon all about. After an analysis that we made in our pilot site in Enercup and Energy Cushing in Spain and Austria respectively, we have identified that in these local distribution grids, they are facing grid stresses due to the stochastic output of the variable renewable energy sources. Furthermore, there is still unstable regulatory framework there, coupled with non-viable market offerings for small consumers. To this end, Merlon comes to provide a complete solution, offering innovative business models where energy communities take the role of DSO or aggregator, and a digitalized holistic solution that integrates a decentralized battery energy storage system with grid forming capabilities, and couple this with technologies enabling the modification of the demand for participation in explicit demand response schemes, in EV integration, and so on. This way, Merlon aims to optimally and holistically coordinate and integrate local flexibility resources by providing accurate renewable generation and demand forecasting and optimal scheduling. This way, Merlon, among the others, aims to contribute to the increase of renewable generation penetration and the avoidance of the renewable generation curtailment. If you go to the next slide, please. So what actually Merlon envisions is to transform, to provide the means towards transforming a local energy system with the weak grid infrastructure. If you go actually one slide up, there was an animation there, so we have lost some information. Perfect, thank you. So Merlon tries to provide the means for transforming a local energy system with weak grid infrastructure to an integrated energy system with active engagement of prosumers through energy communities, where a battery energy storage system can facilitate the even islanding operation and optimal grid management, and all this is an integrated solution that can further support the renewables integration at the local level. And that's all from my side. Hope also to meet the strict timeline. And of course, I'm open to questions during the panel discussion. Thank you very much.
Thank you very much also for the fast presentation. So the next project, Santiago, is...
Yes, the next speaker is Gabriele Comodi. Just a reminder for the audience that you can think very well your questions, because that will, of course, we will address the questions after this session or this slot, but this will give our speakers the opportunity to explain in more than 99 seconds what the projects are about. So my message here is to encourage you to the audience to prepare some good questions that gives them more than this strict 99 seconds. So as said, Gabriele Comodi is Professor Gabriele Comodi is Associate Professor of Energy System at Università Politecnica delle Marche, and he's the reference person of the Italian demo in the Muse Grid projects. Gabriele, you have the floor for your 99 seconds. Thank you.
Yes, thank you. Thank you for inviting me. So I'm going to show you in few slides, which is the Muse Grids project. We are at our final years of the project, and the goal of Muse Grids is to demonstrate how integration of several energy networks can improve flexibility in local energy communities. We are going to demonstrate in real demo a municipal scale local energy community located in Italy, that is Osimo, and a village scale local energy community in Belgium. So in our project, we deal with different energy networks, mainly electricity and natural gas, but also, especially in the Italian demo, with the district heating and water network. So you can see in the picture, in the graph, the load profile of electricity production and consumption in a day of summer. So you can see the typical DAC profile that happens when we have a very high share of renewable energy. So in this municipal scale local energy community, we have up to 23, 24 megawatt of PV. And next slide, please. This high share of renewable share translates in over generation that with the injection of electricity back to the national TSO, that is Terna, and we injected in this demo up to 22 megawatt as a peak during the year. So the goal of the project is to show how flexibility can improve self-consumption of local renewable energy production in local energy communities. We do that by means of well-established technologies and new one. In particular, we have a demonstration of electric vehicles with vehicle to building and vehicle to grid. Controllable load such as heat pumps and smart energy thermal system, but in particular we have storages such as batteries, and in particular, thanks to the project, we have a large thermal energy storage coupled with the cogeneration plant and district heating network, which provide high flexibility to the energy systems. So that's all from my side. I hope to have been on time.
Yes, excellent. You are very well in the time that you have for this presentation. Nikos, I will follow with, if you agree, with George Kariniotakis, who is the coordinator of the Smart for Res research project on renewable energy forecasting and the optimal use of forecast in power systems and electricity markets. He's also working for the Center per se of Mines Paris Tech in France, where he is professor and head of the Renewable Energies and Smart Grids group. He has been working in the field of RES integration in the last 30 years and has been the coordinator of 3 of other large EU projects in this field. For example, ANEMOS, ANEMOS Plus, and SafeWind. George, the floor is also yours.
Okay, thank you, Santiago, for your introduction, and thanks for inviting me in the panel. If you could please the slide. So Smart is a research and innovation with 12 partners from 6 countries. As we all know, the production of variable renewables like wind and solar depends on the weather conditions. For the renewables in power systems, electricity markets, it's necessary to have good forecasts for their production a few minutes to a few days ahead. And such forecasts are used today. However, the accuracy is often not what it should be. So the vision of a Smart Forest project is outstanding improvement in renewable energy sources predictability through a holistic approach that is the whole thing related to forest forecasting. On the left here, we see the typical forecasting model chain that starts from the data. Then we have the weather forecast, the power forecast, the prediction services, and finally the applications that use this forecast for power system and electricity markets. On the right side, I show some highlights of the research in the project. First, we try to improve weather forecasting using ultra-high resolution models. Then we develop models that to predict the renewable production following a seamless approach, able to consider multiple sources of data and different time frames. So if you could change the slide, please. We develop an approach for collaborative forecasting that permits to share data while respecting confidentiality and privacy constraints. And we propose a data market concept to monetize the value in the data. And finally, we optimize the way forecasts are used in power systems and markets through artificial intelligence and a prescriptive analytics approach that aims to simplify the complex model chain. So that's my 99 seconds, and thank you.
Thank you very much, George. Of course, forecasting is very important. Now, before moving to the Slido, shall we ask the audience if there are specific questions to the 5 speakers?
Just a question for Gustavo and Claire. Can you check, please, if the chat is working properly, because I cannot use it. Probably it's just my case, but just in case there is a problem there.
Yeah, just checking now. 1 second.
And meanwhile, as Nico said, all the audience can please go to the slide and answer the last question that we have for today's panel. Okay, Gustavo, I see that is working, but in my case, I cannot use it. But I don't know if the rest of participants can do it. Probably it's a problem from my side.
So we have already 23 people voting. The attendance is about 49 or 48. So that's somebody else wants to vote. Anyway, again, I think we see very interesting results. It supports the idea that in order to really reach the European targets, we need specific support, both at transmission distribution level. You need to basically, so it can host more renewables and also for transmission system. And in both cases, flexibility is very important. And of course, you need tools like better forecast, better production and control, and the problem of reduced inertia due to the power electronics that are decoupling rotating masses from the system. So yeah, all very interesting areas of research. And we heard today about the 4 projects that were dealing with these issues. And first, the one about the large-scale integration of renewables at transmission level by this big EUC's Flex project. The 2 projects that were mainly focusing on distribution and again describing how flexibility would support the penetration of renewables, and then the important, very important need for increased forecasting accuracy so you can operate the system with the right reserves. And of course, the support of the thermal generation storage to the operation of the system with increased renewables. So, are there any questions on these general descriptions?
I don't see any questions from the audience so far, but of course, all of you are invited to raise your hand or just put it in the chat. Whatever is more, it's easier for you. But no questions so far. I just to break the ice, probably I'm going to say that I'm very happy to see that the last poll showed that the role of distribution system operators is very relevant, and since John is here representing TSOs, I would like to know if what does John think about this, and specifically what is the if he can describe in a nutshell which is the contribution of his project to the Fit for 55 ambitious targets.
So yeah, I think it's certainly a very interesting observation in terms of the poll that was taken, and certainly my view would be that it needs all of the above in order for us to reach our ambition. There is significant challenges at a transmission and distribution level, both in terms of the physical infrastructure required to integrate large-scale renewables, to manage the likes of congestion, and also put in the market structures in place and the tools for forecasting and operating in a very complex environment. But if I was to say, what in a nutshell, what the value of the EU SysFlex project, and I'll put it kind of in a negative way in a sense, but what I would suggest is that without a clear understanding of what the technical shortfalls are on the future power system, and without an understanding of how we can respond to those shortfalls, and also without a clear understanding of what the technical capability of plant and systems to provide the necessary system flexibility and services to respond to that need, it will not be possible to design and implement solutions that are needed, and it'll not be possible to reach our ambition by 2030. So I might be putting that in stark terms, but there is a clear need for us to look at things in a new and a fresh way, and what the EU SysFlex project has explored these issues and will provide a roadmap for Europe in terms of how we respond to that future system need to support power system operation into the future.
John, that's a very interesting point or promise that we are going to provide a roadmap how we can solve the technical problems in order to allow this high penetration of renewables in the European system. So can you expand a bit more on that? Do you mean you are going to say what, of course, are the main barriers and obstacles, and a roadmap of how you will solve them by funding research on them? Or what exactly do you mean by this roadmap?
So I suppose firstly, what we're doing here and what we have done is to look at the pan-European system, and we were talking about regions and how you define a region and how we defined regions by synchronous area. So we looked at it from the island of Ireland synchronous area, which I suppose was quite unique in the sense that you could consider it an island system in its own right, which I know there's another parallel session happening at the moment. The continental system, which is a synchronous area in its own right, and also the Nordics. And understanding the technical scarcities that arise within those systems, given our ambitious scenarios, and those scenarios differ for those different synchronous areas, and the challenges that arise differ for those synchronous areas. But what we can extrapolate from what has happened in Ireland as a unique synchronous area is that the higher up you go in terms of renewable integration, the greater the challenge is from a technical scarcity perspective is, and that you need to design market structures and put the right incentives in place in order for investment to be made in the right flexible solutions in order to operate in a very, very high res environment with a very high percentage of variable res such as wind and solar. And we've seen this in Ireland. We're now able to operate the system up to 70%, 75% renewables at any given time. Our ambition is to push that to 95% by 2030 to facilitate our national targets. And the EU, the work we're doing within the EU Sysflex is helping support that. And similarly, that can be extrapolated across Europe as Europe moves towards a greater percentage of variable res. And it's about bringing those lessons forward in some kind of a coherent roadmap, and not only identifying, what we would recommend, but also identifying what future work needs to be done, what future research and investment needs to happen in terms of demonstrations and pilots and so on.
And just another question. In your studies of the pan-European system, do you consider the national plans for raising the wind energy, or do you also propose a different, let's say, philosophy on how we can exploit the renewable potential in Europe? There are such type of discussions, if we are going to have a very nation-centric system where everybody will exploit his renewable resource at the best, or if we would adopt a more European-centric approach where, let's say, we'll invest in the North Sea to the northern parts to provide, or in Ireland to provide a lot of wind energy, and to the south provide more, let's say, solar energy, and then build a system where you exploit the resources where they naturally are better. So what exactly have you taken into account in the long-term planning of the European system?
So while I mentioned 3 synchronous areas, there's also it's significantly important that greater interconnection between those synchronous areas occur in order to maximize the capability across the entire European power system. And we need to move and shift towards a greater integrated system, and different regions, whether they be national regions or pan-European regions or synchronous area regions, supporting one another in order to reach our overall ambition. And I don't believe that we can do it without taking that perspective. If we look at Ireland in terms of its ambition offshore, we're coming from a very low base of practically zero offshore renewable capability to a situation in 2030 where we'll have over 5 gigawatt, or at least that's our ambition, which is almost equivalent to the demand on the system as we speak. So in order to utilize that potential and the greater potential beyond that, we need to enhance our interconnection. We need to integrate systems at a European level in order to export that energy that is not being used, or to use it in different ways. And it goes beyond that. I think it goes beyond the electricity system. We need to look at things in a much more holistic way, and a whole system thinking, and looking at, the power to X, hydrogen, so on and so forth, and how all of that can be integrated into a whole system. Beyond the scope maybe of Sysflex, but certainly that's something that is a consideration.
Thank you very much, John. Let's move to the next project, Merlon, to Katharina. Santiago, do you want to ask something, Katharina? You are muted.
Yes, already almost 2 years with the Teams meetings, and I forgot to unmute myself. So no, yes, probably the same question, but in the case of Katharina, I was glad also to see that she has included in her project the Spanish cooperative Enercop that I very know. I know very well. But in my case, I would ask her which is the most important thing to do to involve energy communities in integrating renewables. I mean, it's clear, as John said, that it's a holistic approach is needed. But then, in the case of Merlon project, it's clear that a more local approach is needed. So I would like to ask Katharina, which more do we need to have this participation, this engagement of local communities and cooperatives and so on. Thank you.
Thank you very much, Santiago, for the question. Actually, first of all, just to mention that everybody has problems with Teams, even if we use it for a long time. So it's a common thing. So coming to your question, yes, indeed, not only in Spain, but in Merlon, we also have in our pilot site EE, which is an energy cooperative in Austria. So we, in both pilot sites, we investigate how energy communities can play different roles and support the holistic integration that Merlon proposes. From my point of view, and actually what Merlon has suggested, is that indeed prosumers engagement is a critical factor in order to enable the utilization of flexibility at residential or commercial buildings. To this end, we can take advantage of energy communities, actually, because at energy communities, people are already sensitized environmentally. They have interest, apart from reducing their cost savings, to contribute to the European decarbonization plan. So we can take advantage of energy communities and give them specific incentives in order for participating in specific market structure and business models that can enable the optimal coordination of the local grid, which in turn can, of course, facilitate the increase of renewables penetration at the local level.
Santiago, can I continue on this same topic?
Sure.
So,
yes,
really incentivizing the consumers to turn them to active citizens is probably the most difficult part of this transition. This has been proven so far. So how do you manage to incentivize people to join energy communities? And you mentioned in your presentation that you have devised some advanced, you said, business case models or something like that, no? Advanced business case models. So can you expand a bit on this? How do you manage to make people becoming active and joining energy communities?
So first of all, just to mention that the pool of actual users that are going to be used as aggregators pool that will be used for demonstration in Merlon are not so high. We have 10 actual users in the Austrian pilot site and around 15 to the Spanish pilot. However, we have established a living lab where we have bring together all stakeholders and we try to communicate Merlon scope to them with a simple words. People want to, everyday people does not care about the technical details. They are very frequently, we can grasp their attention through nice and intuitive user interfaces. So we pay special attention in delivering things that make trigger them and grasp their attention in order to join not only Merlin but generally an energy community. So this is for the first part of your question. And as regards the business models that you mentioned before, in Merlin we have explored how an energy community can take the role of DSO or aggregator. So they can collectively gain some benefits through assuming such roles. A main business model examined in the project is local distribution constraints management. So we investigate how the holistic framework proposed along with the battery energy storage system with grid forming capabilities can alleviate thermal constraints in the network. So you can imagine that in both areas we have a local energy community that it is like operating their own grid. So they have we build mutually incentives that can support the overall business model explored in the project.
That's very interesting, because I would think that playing the role of distribution system operator is extremely complicated, and really it needs a lot of knowledge and experience to be able to operate securely a distribution network. So giving this role to the members of the energy community, I would find that to be difficult. However, perhaps it has some advantages in business models, in the business case.
Just to mention that in the cooperatives, both cooperatives examined in the project are somehow different legal entities that have already a relationship with the local DSOs. So these are the main representatives that we assume such role, but considering that we consider the whole community taking such roles, of course, the benefits would be shared. However, of course, the operation is at the hand of the more, let's say, knowledgeable people that are involved in the DSO part.
I see. Okay. Okay. And then there is a question in the chat. I don't know if you can also answer this, that how do you operate control the different DR? I mean, how do you mentioned about grid forming inverters. So again, how is the knowledge in the local energy community to be so technical? Because that's a very modern and quite difficult topic on how to deal with grid forming inverters, right? This is now a very hot research topic.
Yes, and this is one of the main innovations that Marlon introduced. Actually, we have an expert on battery energy storage system in the consortium, Cobra, that was responsible also for making the sizing, the procurement, purchase, installation, commissioning of the battery energy storage system in both sides. So the whole approach was developed within Merlin, and both batteries are now in place, and we are currently in demonstration phase. So in the case of Merlin, of course, we relied at the hand of this expert partner that made the whole studies, guided the pilot partners, which was, as I mentioned before, DSOs with the help of the local energy community representatives. And we make the whole study for the purchase, installation, and commissioning of the battery. Of course, one thing that I would like to mention, and it has to do also with the polls that we checked before regarding on where we put we need to put effort on research and innovation, is that what we found in the Austrian pilot site is that for enabling an actual islanding operation, further protection measures need to be considered in the local grid. So it is not so easy, even if you have the technology of the battery with the capability to offer islanded operation. This does not mean that this can easily be replicated in another network, because there are specific regulatory constraints for protections and so on that should be upgraded in order for such a scenario to be realized in real life.
Yeah, even if we forget the regulation, it's a technically difficult problem to operate islanded. Anyway, yes, thank you very much, Katharina. Let's now move to Muse Grids, Gabriele, and the word back to Santiago.
Yes, thank you, Nikos. Very good questions and answers till the moment. I think the audience can also try to provide some more ideas for this. The thing is that I've not seen any question. I don't know if it's a problem from me, or it's just that the audience is quite silent till now. But in any case, I have a question for Gabriel. That you Gabriel, you described a very practical approach with your demo sites, and I was particularly interested in with the use of vehicle to battery and vehicle to grid, because as the member, the co-chair of the working group 1 in ETIP SNET, we are preparing a paper on the impact of electric vehicles in the grid and how to deal with it without trying to cause big problems, big issues for the grid management. So my question to you would be, which is your view on the contribution of electric vehicles, of electric vehicle charging, to maximize this efficiency in with energy integration of the different vectors, heating, mobility, etc. How do you see it? That is my question.
Yes, thanks for the question. So just a summary of our project again. So we deal with two local energy communities and in both we have electric vehicles, and in one of them we have also batteries. So in both we have both electric vehicles and batteries, and in one of them we have also let's say thermal energy storages. So I mean that in that sense we mainly deal with distributed generation. So for instance, in the city of Osimo we have 37 megawatt of renewables. Let's say yes, 37. We arrived to 38 by considering 1 megawatt of cogeneration plant. So most of these we have more than 1,000 distributed generation resources. Only 3 of them are have a capacity higher than 1 megawatt, and we mainly deal with rooftop and distributed generation PV. So, which is the role of electric vehicles and batteries. Let's say that first of all, with regard to the electric vehicles, of course, we are facing a phase of transition toward electrification of mobility. So the idea is that we are in our demos, we are installing electric vehicle charging station, and the idea is to have, let's say, a grid to vehicle flexibility profile. So at the moment, what happens when you plug in your electric vehicle is that the power that is provided is the maximum power that can be allowed by the electric vehicle charging station, and then you charge your batteries until it is fully charged. So what we are testing in our demo is mainly to define a different profile of charging, different charging profile in order to provide flexibility during in the public electric vehicle charging station. I underline the public charging station because when we deal with vehicle to building and vehicle to grid, we must do that, and we do that behind the meter. I mean, it is not possible for Italian regulation to provide electricity back to the grid. So what we do in our demos is to provide flexibility, vehicle to building behind the meter. So we have in a smart building that is also what we can call a collective self-consumption low energy community. So we have a smart building with several point of delivery. We have here batteries, we have here controllable loads, we have PV, and we have also a vehicle to building charging station. So the role in this sense is that we can use electric vehicles fleet like distributed energy storage. That cooperates, let's say, with the building energy management system in order to maximize self-consumption of renewable energy installed in let's say, in the building. With regard to the effect of electric vehicles in the profile of the local energy communities, I mean, the main idea that we have, the main results is that it is difficult to change patterns of electric vehicle users. I mean, I don't know if you recall my picture, but we have overgeneration in our demo in Italy. So, and this overgeneration is always happens during weekend because we have a lack of, let's say, lack of energy demand because most of industries are closed. So, in order to provide flexibility and to use this overgeneration, we should ask to people to charge their electric vehicles during summer weekend. That is the typical hours in which they go to the to holiday. So during weekend. So
that was exactly my question. I mean, you explained it very well. I mean, our problem is we want people to consume energy, excess of energy from renewables just in the time that they can charge the vehicles. But my question was, are you having this kind of response from users, or we need to do more to try to couple the two needs? The needs from when we feed in with excess of renewables, that it's a bad thing, let's say, for system operators, and then to have this source of use or utilization of the energy.
Okay. Yes. So what we are doing in our project is to let's say to define a couple of strategies on that. The first one is related. So it's not possible to change the consumption pattern of let's say private people. Okay, also it's different for them. It's easiest for them to make let's say a rooftop PV with the let's say wall box charging station for their own use, and then they are aware on how they consume it. So maybe they maximize their self-consumption without affecting the DSO, maybe increasing their self-consumption. But what we are doing to let's say to address the problem to face the problem of overgeneration during weekend is to work with industrial companies fleet. I mean, most of the same company cooperating in our demo has a fleet of electric vehicles. And what we are trying to do is to, let's say, have the electric vehicle fully discharged on Friday in order to maximize their consumption during weekend. But in any case, at the moment we are dealing with few electric vehicles, let's say 5 or 6. So it's not possible to completely address the overgeneration during the weekend. But in any case, we can set up the, let's say, this kind of let's say energy management system. But there are a lot of small problems. But for instance, if we have a fleet of let's say 10 or 15 electric vehicle cars that have to charge during weekend from 8 a.m. until 18 p.m. So the idea is that you must have all the electric vehicle connected to the grid, because otherwise if you want to charge them in row, you need that all of them are connected to the grid, because otherwise you need someone that once the first vehicle is fully charged, then goes to plug in the other one. So I mean, there are several, let's say, small issues on that. The idea is that probably in this building we have a mix of generation of storage technologies. We have also batteries that integrates the electric vehicle charging station. And in the medium term, we expect in any case that electric vehicle could be an asset for aggregator to, let's say, provide the flexibility to the DSO. But it is difficult to change consumption, let's say, charging patterns of electric vehicles, because the main driver is not, let's say, energy transition, is mobility. So we have to match these two goals. And with regard to batteries, so because I think that you also asked about batteries, we installed a couple of batteries in some branches of the DSO network, because especially out of the town where we have large power plants and low demand, we have some voltage problems. So we have installed a couple of batteries in order to maybe solve some congestion management problem.
Okay, thank you, Nikos. Because I saw that probably he was having some troubles with his connection. If not, as said before, I'm not seeing if there is any question from the audience in the chat. Gustavo, could you please confirm that there is no question, because we already have some trouble with the chat.
The last one was from Oscar Seone regarding the different. I think we already addressed that one possibly though, but the last one was from Oscar.
Okay, thank you.
Yeah. I'm sorry I was disconnected. I'm sorry.
Nikos, it's over to you, because Gabriel just finished his answer to my long question.
Good. Thank you. Gabriel, some more questions for me. So you spoke about 37 megawatts of renewables. This is, I guess, is not part of the energy communities that you are installing. This is in a larger region of.
Actually, it is. So one of our demo, the Italian one, is let's say our project was within the energy non-geographical energy island. So actually, in this municipality, we have 37 megawatt that are in the DSO network, and the DSO network is an energy island below the primary energy cabin from the TSO. But of course, these 37 megawatt are not from the project. I mean, it is, let's say, the results of incentives program of in Italy about renewables. So we have, let's say, 35 megawatt of PV, but we also have something like 200 kilowatt of mini hydro into power plants. We have 1 megawatt of biogas, and we should have, but I'm not sure, something like 200 kilowatt of biofuels and liquid biomasses. So all this kind of distributed generation resources. So all of them, most of them, let's say 95% is less than 1 megawatt, and 10% is higher than 50 kilowatts. So it means that more than 1,000 plants are lower than 50 kilowatts, and they are mainly PVs.
Okay, thank you very much. Okay, let's move to Smart for RS. George, any questions, Santiago?
Well, yes. In fact, I was also very interested in hearing about this project, because forecasting is something that is definitely a key tool for trying to understand or to prepare for the higher integration of renewables, not only from the market or renewable generator perspective, but also from the system operators, DSO, TSOs. Also, they can know ahead where the congestion could be in high feeding scenarios. So I will ask George, which also in a nutshell, what would be the learnings of your project for the not only the market, but also for the system operators, in order to have them right in place to manage better their grids and try to avoid problems when we will have in the next years this high amount of renewables in our grids.
Okay, so the system operators, DSOs or TSOs, have already quite large experience in using forecasting tools. They have developed their own. They buy services by the different companies that provide forecasts. Now we are more in a phase where they buy multiple forecasts by forecast providers, because they want to have the best products. I think what the TSOs and the different stakeholders is necessary to realize is that good forecasting products is a kind of alternative or very complementary to remedies we discussed today about flexibility, like storage, like enhancing the grid, etc. I mean, if we manage to reduce, for example, the errors, the forecasting errors of wind production or solar production by some percentages, this translates immediately to benefits in terms of investments. We have to invest less storage because we have to balance less the prediction errors. We have not to forget that in practically in all applications, the management of the systems, the energy system, it can be a distribution grid, a transmission grid, a microgrid, an energy community is done at two scales. One is the predictive scale, time scale, where we take decisions what we do in the next hours, days, and then we operate the system as a function of what happens. Now, if the decisions we make in the predictive scales are not good, then we need to have a lot of storage. We need to activate flexibilities. We need to do many things to operate the system. Of course, we are not going to have ever perfect predictions, because we are not able to predict perfectly the weather conditions of wind or solar plants. But well, the question is, I think the first thing to keep in mind is that we always want to have better predictability, especially in the years to come when we will have more and more penetration. So the first learning is that there is always a margin to improve, and what TSOs and the different actors anyway should keep in mind is that to favorize innovation and not just say, okay, that we buy today a product from a company and we have our forecast. I think what we have shown in the project is that there is potential to improve predictability, but you need to accompany these efforts with the necessary efforts to favorize innovation to that direction. For example, one of the everybody speaks about digitalization and data. We want to have open data, a lot of data, and now we have new measuring technologies for renewables like LiDARs, radars, sky cameras, satellite images from different satellites, etc. And all these are there. But okay, how can you extract the value of this data? We have seen, for example, in a case that for the case of Denmark, that if you use just the data from the neighbor sites of the neighbor wind farms, you can improve the predictability of wind production for the next 6 hours by 20%. And this is by just using the data that are available. So one thing is to favorize innovation. The second thing is just to favorize the exchange of data, which is not. There are bottlenecks today, so that this can be integrated in the different forecasting processes, etc., so that you can extract really the value that you can have out of data. So these are 2 points I would like to mention for the moment.
So if I am understanding it well, you are encouraging system operators and all the rest of agents not only to use the existing tools, but also to investigate and to develop their own projects and experience in forecasting, as they can use it for their own purposes and extract the good values, and of course exchange data with in this case, for example, with the power plants that are connected to the grids. In the case of TSOs, probably bigger plants, but in the case of DSOs, probably connecting with the aggregators of whatever.
That's right. Also, we see today that there are, for example, new needs for forecasting. Like, for example, when we ask renewables to participate in in ancillary service markets, and there you need some specific forecast, for example, because you want to provide forecast of some level of guaranteed power with a very high reliability. Because when you are called to provide the regulation upwards or downwards, you have to be reliable. You can have all the controls to do it at the level of the wind farm, but if you propose, I don't know, for your wind farm to reduce some megawatt and the power is not there, you cannot do anything. I mean, if your forecast when you promised this ancillary service was not good, you cannot do it. So what we see that in this changing context with higher renewables is that it's not only to improve predictability, but also to develop new solutions for the new applications like ancillary service provision, etc. And this is challenging. So and what we see is that if we take check the history in the last 10 years. Smart Forest is, for example, the only project financed by the European Commission a research project on predictability of renewables. You can find forecasting in many demonstration projects where you apply more or less or you do some incremental research, but you don't have really collaborative work at European level. In the last, you do not have it in the last 10 years, where you think a bit out of the box and okay, you say what we do together to improve these issues in this difficult problem. Actually,
George, your last statement is really very important. I mean, you have been leading European research on forecasting for many years. We have coordinated the biggest European projects I know, at least, which are the Anemos Plus, SafeWind, and now the Smart Forest. But he's really focused on forecasting. And you partly answered, but I would first like to know what is the accuracy we have reached so far. I know this is a very general question, depends on the case, but can you give us some indication of how much accuracy you could expect for forecasting wind and solar, of course, I mean for operational reasons, for the next hour or 4 hours or 8 hours? And then
if I may interrupt,
what is really...
Nico, sorry, if I may interrupt, for George, just a brief answer, because we have still Alexander waiting, and his view is very valuable. So, Nico, sorry to interrupt. Just was a remark on the time. Sorry.
And you answered more or less, of course, what we would expect from new research. But yeah, just a quick answer to my first question, and then we move, of course, to Alex. Yeah.
Okay, where we are at the level of a wind farm or a PV plant, a single one, because when we are in the aggregations, you have a smoothing effect.
Yes.
Then you are at a level of 8% or 10%, depending on the conditions, the weather conditions, or the terrain complexity of error, percentage of the nominal capacity. Generally, let's say, this is not important, actually, this percentage. What happens is that, let's say 80–90% of time, the forecast systems are good because we have the knowledge to predict the weather conditions. I mean, when we predict sun, it's not always rain the next day. So, however, there are 10–15 percentage of cases where we fail to predict because we fail to predict weather, etc., or we have fronts that are coming and we predict wrongly the timing of the fronts. And in this case, actually, these cases are the case which have a high impact. You can have a model, like we had seen some case from EnergyNet, for example, where you can have 90% of the time good forecast, but you can have a few situations which can lead to disastrous situations, and the impact, the monetary in terms of safety, etc., can cancel all the benefits you can have from the rest. So the question is not to improve generally forecasting, but try to improve these situations which have a high impact for the system in terms of security and economic operation, actually.
Thank you very much, George. Now, let's move to Alex and back to Santiago.
Yes, thank you very much. Of course, I'm as member of the ETIP SNET, I'm the host, and it is, of course, a good manner to focus on the projects of our guests, which were here introduced. And I was also very carefully listening to your projects, and I think these are very, very important puzzle stones for the decarbonization, because I think there's a high potential in these kind of local living labs and sandboxes, which you have illustrated here. And it is very important to address the problem to just saving the energy resources, using them if the demand is low, and so on. I think this is very, very important. I appreciate your projects very much. And what I would like to highlight, maybe in addition to this, from the point of flexible generation, is that we are looking to serve all the sectors. And one of our sectors of great concern, of course, is also the energy efficient industries. So Europe is a highly industrialized area. And unfortunately, of course, a lot of those areas are also in the northern part, which are not blessed with a current flow of sun or wind. And on the other hand, if you may look around and you look into your computer and you see that many products, of course, whose feedstock is carbon. So this is true for all the plastic industry, chemical industry. This is true also for cement and so on, concrete and so on. And of course, to produce this also needs a lot of energy, and this, of course, has to be provided in a sustainable way, and also very reliable and also affordable to keep our industry, of course, also competitive. And insofar, I think that you have addressed some issues which are very important also for the large scale. This is combined heat power. This is also storage by, say, batteries. The automobility sector. And so in addition to this, we urgently need also to invest into storage on a larger scale. And this is this can only mean storage in the scale of, say, liquid air energy storage, things like mechanical storage, thermal storage, and at least also in the generation and also the usage of hydrogen. In particular, if you look into the automobility sector, you were talking about personal cars, but looking also on the marine and the aviation sector, probably some ideas like SAF, sustainable air engine or airplane fuels and so on. This is a very important matter. And in addition to this, I think that probably also in Europe, we will never be self-sustained with energy. We import energy right now, and we will also probably import energy in the future. That means we need to set up probably also international hydrogen network, which is very important. And of course, looking at the energy-intensive industry, I also see a certain justification and for CCUS, carbon capture, utility and storage, because the carbon will still be needed as feedstock in the future. And of course, it also makes sense to just not only to focus on 100% green energy, but also looking at the potential which will give us the so-called blue hydrogen generated out of fossil fuels or fossil resources, which we probably will need for many of our products we are using and we are relying on.
Alex, the time is up. But there is a question in the chat that you might want to answer in 1 minute. It says, how can, you spoke about industry, about big industry.
Yes.
The question is, how can small and medium enterprises, SMEs, to contribute to the required flexibility by using manufacturing processes? Can you give an idea of how small industries can help in flexibility?
Yes, of course. So small and medium enterprises have the know-how in particular in digitization, and they can help to just optimize production processes using more digitalization. Also saving resources by just taking into building some kind of digital twins for all the lifetime of new products, and just side by side with the energy saving, of course, also the saving of resources at all is one of the very important points, which will keep our world intact and also helps us to help us to keep the climate levels at that point which we are just aiming at.
Good, good. Thank you very much. So, Santiago, I think it's time to close the session.
It's time to go. Yes.
So let's thank you all.
Many thanks to all the panelists. Very good discussion and very good insights here that I will be briefing them in some minutes, but now all of us have to go to the general session, except I guess Nikos and myself have to remain here to discuss.
Yes, we have to work.
Yes. Thank you very much to all. See you in a
Okay.
moment.
Thank you very much.
Yeah.
Thank you.
Bye-bye.
Thank
Thank you.
everybody.
Thank you.
Bye.
Bye-bye.